18 light years, in cosmic terms, practically next door. On the 1st of October 2025, at 0047 hours Coordinated Universal Time, something remarkable happened over Antarctica. 428 kilometers above the eternal ice, closer than the International Space Station, an object tore through the night. A rock from space, the size of a small car, traveling at 21,000 kilometers per hour. No one had seen it coming. 8 hours later, an unremarkable morning in Arizona, the Catalina Sky Survey. One telescope among many. Routine work. The astronomers compare images of the night sky, new pictures against old ones. They search for movement, for objects that don't belong among the stars. And then, a dot. A single faint point of light on the images. Something that shouldn't be there. They name it 2025 TF. But when they calculate its trajectory backward, they recognize the disturbing truth. This asteroid had already passed Earth, hours ago, while they slept, while a billion people went about their daily lives. 428 kilometers. That's the altitude where our astronauts live. In the space station, we can see crossing the night sky. An asteroid, 1 to 3 meters across, had raced past us at that height. And no one had noticed. 24 hours later, it happens again. A second asteroid, 2025 TQ2, this time over Canada, 4,851 kilometers away, still closer than the diameter of our own planet, again discovered only after it had passed. What happened here is not an exception, it is the rule. Let me tell you about a blind spot. A region of the sky we cannot see, must not see. The sun, every telescope on Earth has a fundamental limitation. It cannot look toward the sun. The blinding light makes it impossible. During the day, the blue sky drowns out the stars. At night, the region near the sun is invisible behind the horizon. 1/4 of the night sky, gone, invisible. And that's exactly where 2025 TF came from. Its course lay within 15 degrees of the sun, in the shadow of light. But the story is older, much older. February 15th, 2013, Chelyabinsk, Russia, 9:20 a.m. local time, an ordinary winter morning, minus 15 degrees Celsius. Then, a light in the sky, brighter than the sun. An asteroid, 20 meters across, 9,000 tons in mass, 19 kilometers per second through the atmosphere, coming from the direction of the sun, undetected, until the final second. The explosion had the force of 500,000 tons of TNT, 30 times more powerful than the atomic bomb dropped on Hiroshima. 7,200 buildings damaged, 1,500 people injured, most by broken glass, by pressure waves, by shock waves that arrived minutes after the flash. Paul Chodas, manager of NASA's Center for Near-Earth Object Studies, was sitting in a studio that day. He was supposed to talk about a different asteroid, 2012 DA-14, a harmless object that would pass Earth at a safe distance. Then the news from Russia reached him.
A YouTube video, an explosion.
At first, he thought it was a fake. It wasn't. Neil deGrasse Tyson, director of the New York Planetarium, later said something remarkable. The Chelyabinsk meteor was unpredicted because no attempt had been made to find and catalog every 15-meter near-Earth object. No attempt had been made. Not because we didn't want to, but because it's nearly impossible. The numbers are sobering. We have mapped over 33,000 near-Earth asteroids. We know over 90% of the large objects, those a kilometer or larger, the planetary killers. But the smaller objects, the city-sized asteroids, those 140 meters or larger, 40% are known, 14,000 remain undiscovered. And the even smaller ones, the Chelyabinsk size, 20 meters? The majority is invisible until they come. Do you understand what this means? At this moment, over 8,700 Starlink satellites orbit above our heads. Communication networks, GPS systems, weather stations, the infrastructure of our modern world. Most are in an orbit between 160 and 2,000 kilometers altitude. 2025 TF flew through this zone, 428 kilometers high. Had its trajectory been only slightly different, just a few kilometers off, it could have struck one of those satellites. No explosion, no warning, only silence in space. And then on Earth, GPS signals would fail, communication networks would collapse. But there's a deeper truth. These small asteroids, like 2025 TF, statistically strike Earth every 60 years. This isn't speculation, this is observation. Chelyabinsk, 2013. Tunguska, 1908, 750 square kilometers of Siberian forest, flattened to the ground, fortunately uninhabited. 1963, Southern Indian Ocean, Prince Edward Islands. An explosion, possibly a meteor, no one was nearby. Every 60 years. That's the frequency. And with each passing year, our civilization grows. More people, more cities, more infrastructure in orbit. There are plans. Of course, there are plans. The Surveyor mission, an infrared telescope, planned for Lagrange point L1, between Earth and Sun. From there, it could see into the blind spot toward the Sun, into that region no Earth-based telescope can reach. The project was first proposed in 2006, 19 years ago. Applied 5 times, rejected 5 times. Only in 2019, after another dangerous close flyby, was it approved, outside NASA's normal science budget, from planetary defense funds. On February 11, 2025, it passed its critical design review. It will take years before it launches, years before it delivers data. Until then, the blind spot remains. On the 1st of October, 2025, an asteroid passed Earth at an altitude where humans live. We discovered it 8 hours too late. This is not a story about danger. It is a story about limits, about the limits of our perception, about a sky we cannot fully see, about a reality we only understand after it has happened. The next such flyby could be tomorrow. Next week, in 60 years, we will know when it's over.